right here. I know it's a bunch of letters, but what does that mean? So if you look at it in terms of numbers, 3 squared is 9. You know that, right? So if I write it as a logarithm, the base is 3, so it's a log base 3 of 9 equals 2. So what's happening is the power is the answer. The base is the base of your logarithm. And then the result is where that logarithm sits. Do you see it? Your job is to be, on the first kind of questions, is to rearrange. Either you're given the logarithmic version and you make it in exponential, or vice versa. So in the video, I showed you if they gave it to you like this, then I'd just do the swirl thing to get it out. So 3 squared is equal to 9, and that's how I would get there. Now going in the opposite direction, I have to stop and tell myself, okay, what is the base of the exponent? That becomes the base of the logarithm. The power is my answer, and the other number just goes in that other space. All right? So part of your practice today is to be able to rearrange, to go from exponential to logarithmic, logarithmic to exponential. So that doesn't require a calculator, it's just you learning where things go. Okay? And the calculator's not going to do it for you either way. So, let's see. Let me come back here, I'll do a couple of these. So like, write the logarithmic equations in exponential form. So this would be 6 squared equals 36. Yep, 6 squared equals 36, right? What about this one? This is a fraction, it's weird. Just follow the rule. Start with the base, 7, swirl it out. To the negative 2 is 1 over 49. You guys remember negative exponents? Maybe, possibly? Negative exponent. Yeah, let's say it's a to the negative 2. That becomes a to the 2. So you banish negativity to the basement, however you want to say it. Okay, that's how it becomes positive. So just remembering those properties of exponents is pretty important here. Is that okay? This one also brings up another property. The square root of a number can be written as that number to the 1/2 power. So if it was a cube root, it would be to the 1/3 power, and so on and so forth. Okay. So like this one, if I rewrite it in exponential form, what's the base? Yep, 32. What's the power? Power is this piece right here. To the 2/5 power equals 4. All right. And then this one. 2 to the 1/2 power is equal to the square root of 2. That's all you'd have to do. So you can see, calculator's not going to really do it for you on this anyway. You've got to realize this relationship. Now, on this section, we just rearranged. We flipped it. Now it's an exponential. You got to write it as a logarithm. Okay? The base is the base of the logarithm. So start there. Log base 81 of 3 equals 1/4. That power is your answer. So what about this guy? Base what? Base G of 4 equals A. Good. What about this one? Log base what? Of what? Equals negative 2. You got it. So that's just rearranging. Now these properties down here are going to help you as you solve. And you're going to find if you know your properties, you don't need a calculator. That's the purpose of this lesson, okay? Log base anything of 1 is equal to 0 because any number to the 0 power is equal to 1. So if I rearrange it into logarithm form, it looks like that. So you see, if you see the log base anything and it's 1, you can replace it with a 0. Right here, log base a of a is equal to 1. And why is that? Because if I put that in exponential form, it's saying a to the first power is just a. Whatever a is. Could be 27 to the first power, still 27. Right? Now, this one looks a little bit strange, but look, log base a of a to the x is equal to x. So notice, if these two pieces right here are the same, they kind of cancel out, don't they? And that x is your answer. So you look for patterns like that to help you solve, all right? And then the reverse is true. If I said a raised to this wonky looking power, what really matters here is that the bases are the same. So then they would cancel and it's just x. Simplifies quite a bit, doesn't it? And then the last little property that will help us a ton when we get to actually solving for numbers is notice if you have two logarithms. Now notice it's just logarithms. There's nothing added or multiplied or anything to it, right? Two logarithms, but they have the same base. Those logarithms will drop out. They cancel each other out, and then you just have x equals y. All right? So just have any in-class examples on it? Walk you through just a couple little examples of what you're going to be doing today, and then I'm going to turn you loose. I don't really have in-class examples, and so you should have seen these already. But I'll do, all right, you pick one of these, 1 through 3. Which one should I do? 2. All right. So if it doesn't have an equal sign, and you feel more comfortable with an equal sign, put that on there, okay? It is saying, if I swirl this out, it is saying 5 to what power is 5 to the x power? It's just x, isn't it? I don't really know what x is, but it's going to be the same. So are your answers always numbers? No. Okay. Look at 3. What's that one going to be? Yeah, 7 to raise the log base 7 of anything is just whatever that number is. So it's just 14. These are in your notes. I don't have any in-class examples, so I'm going back over some notes things. Okay? What about, let's do number 8. All right, so if we want to swirl it, 10 to what power is 1 over 100? Well, what's 100 in terms of 10? 10 to what power is 100? 2. So I could write it like this. 10 is equal to 1 over 10 squared. And then what could I do to make it not a fraction? If I move it up, this becomes, I'm leaving that 10 to the x, this becomes 10 to the negative 2, right? So then what is x? Negative 2, because the bases are the same, the powers drop down, so my answer is just negative 2. Is that okay? What's wrong? What's wrong? It's raining, but guess what? We're inside. We're not getting wet. It's okay. That don't mean it's going to be raining like this in 30 minutes. It's fine. It's on and off. Breathe. You're fine. Lord. All right. So let's do this one. Number 9. I always put it equals to x, and then I swirl it out. So 2 to what power is 32? How could I find that without a calculator? Huh? 2 times 2 times 2 until it hits 32, right? Yeah. Okay, let's do it. 2 times 2 is 4. Times 2 more is 8. Times 2 more is 16. Times 2 more is 32. That's what we want. So how many is that? 1, 2, 3, 4, 5. So this is 2 to the 5th, right? So my answer is 5. We good? It's all about the powers. Got to know your powers. All right. Now, last little bit down here. This is where we apply those properties that we talked about. So like on 13, log base 3 of x equals log base 3 of 7. What do they have in common? They're both log base 3s. That means I can just cancel out the logs and x equals 7. What about 14? Log base 6 of 6 to the 5th is? It's just 5. Yeah. Why? Because if I swirl that out, I'm saying 6 to what power is 6 to the 5th? It's 5, right? See it? All right, look at this one. What about log base 4? Those cancel out, so I have x equals 2 to the negative 5th. What is that, though? What do I do with the negative 5? So it's 1 over 2 to the 5th, right? And I can figure out 2 to the 5th. We already said this one was 32, so it's 1 over 32. We're getting there? Last one. This is one of my favorite uses of the property. Notice, what do these two sides of the equation have in common? Log base 9. Now, pay attention to this. See the 2x plus 1? All that's in parentheses. The reason this property works is because all you have is the log and its guts. Here's the log and its guts. All right. Since log base 9 is the same, I can just cancel them out and write it as an equation. This is algebra 1 now, isn't it? So I move the 1 to x equals 6, so x must be 3. Boom. That's it. That's as tough as it gets today. All right? But you got to get this skill down so we can ramp it up to college level. All right? So do the practice. Don't forget you